Hundreds of millions of kilometers away from us lies a mysterious celestial body full of unknowns, whose influence stretches across the entire solar system. Today, I'd like to introduce this enigmatic planet, Jupiter. What you're seeing right now shows the actual positions of all planets in the solar system. Right in the center sits the Sun, moving outward from the innermost orbit. We have Mercury, Venus, Earth, Mars, and then Jupiter. All these planets revolve around the Sun, as you can see from this model. Jupiter is extremely far from Earth, and this distance is never fixed. Since both planets orbit the Sun along non-circular paths, the gap between Earth and Jupiter falls into two distinct ranges: opposition distance and conjunction distance. Conjunction occurs when the Sun, Earth, and Jupiter align in a straight line, with Earth positioned between the Sun and Jupiter. At this point, Jupiter comes closest to our planet, roughly 590 million kilometers away. Opposition, by contrast, is another straight line alignment of the three bodies. This time the Sun lies between Earth and Jupiter. This marks the maximum separation between Earth and Jupiter, around 920 million kilometers. Even at its nearest approach, reaching Jupiter from Earth is an epic journey. Light traveling at its maximum speed still needs about half an hour to make the trip. If you boarded a China Railway CRH bullet train traveling at its top speed of 390 kilometers per hour, running non-stop day and night, the voyage would take roughly 184 years. Given the natural human lifespan, no one on board would live to arrive. Jupiter claims many superlatives among the 8 planets of the solar system. It is the largest by volume and rotates the fastest. Its mass adds up to 2.5 times the combined mass of the other 7 planets put together. Its diameter is 11 times that of Earth. If Jupiter were hollow, more than 1,300 Earths could fit inside it. It completes one full rotation in just 9.9 hours, far shorter than Earth Day. Yet its orbital period around the Sun is lengthy. Jupiter orbits the Sun at an average distance of 780 million kilometers, taking roughly 12 Earth years, over 4,300 Earth days, to finish a single loop. Additionally, Jupiter's gravitational pull dwarfs Earth's, about 2.5 times stronger. If you weigh 50 kilograms on Earth, you would tip the scales at 125 kilograms on Jupiter. Thanks to this immense gravity, many scientists believe Jupiter acts as a cosmic shield for Earth. It draws countless asteroids and comets that could otherwise pose a threat to our planet toward itself. The name Jupiter may sound calm and gentle, but do not be misled. This is no lush, life-bearing world. On the contrary, it is an utterly terrifying celestial sphere, also known as the Death Planet. Mars, the Moon, and Earth, which we've discussed before, are all rocky planets. Jupiter, however, is a gas giant or Jovian planet, composed primarily of hydrogen and helium. It has no solid surface like Earth, meaning there's nowhere to stand if we were to arrive there. We would simply free fall inward. Jupiter's gravitational acceleration is 2.5 times Earth's, creating an overwhelming downward pull. During the descent, ferocious Jovian winds would toss us about relentlessly. Wind speeds on Jupiter never drop below 320 kilometers per hour, far faster than the takeoff speed of an airplane. Near the Great Red Spot, gusts reach 430 to 680 kilometers per hour, an astonishing constant wind speed, not fleeting blasts. With such brutal conditions on Jupiter's outer atmosphere, you might wonder if conditions grow milder deeper inside. Unfortunately, the environment only grows more hellish the further you plunge. Jupiter's atmosphere extends thousands of kilometers deep. Its upper cloud tops plummet to roughly minus 150 degrees Celsius, yet pressure and temperature soar as you near the core. We know Venus's surface maxes out at 480 degrees Celsius, but Jupiter's interior heats up to tens of thousands of degrees. Any object falling into Jupiter will instantly incinerate and vaporize entirely. Astronomers estimate the core's peak temperature could hit 50,000 degrees Celsius, though this remains theoretical. Humans have yet to develop technology capable of reaching Jupiter's depths. deep within the planet. Hydrogen condenses into liquid, forming the largest ocean in the solar system. Though not an ocean of water, but one of liquid metallic hydrogen. Light cannot penetrate these depths, so there is no distinction between day and night, and no oxygen whatsoever. No form of life, as we know it, could survive such extreme conditions, cementing its title as the death planet. While Jupiter itself cannot sustain life, many scientists have turned their attention to Europa, one of its moons. Beneath Europa's icy crust may lie a liquid ocean, a potential cradle for life. As of May 2023, astronomers have confirmed a total of 95 moons orbiting Jupiter. The four largest are called the Galilean moons. First observed by Galileo Galilei in 1610, the very first celestial bodies discovered beyond Earth's orbit. They are Io, Europa, Ganymede, and Callisto. Each of these four moons possesses unique traits, making them prime targets for scientific research. Io is remarkably large, slightly bigger than the moon and 20% more massive, ranking as the fourth largest moon in the solar system. It is also the most volcanically active object in our planetary system, home to over 400 identified volcanoes with violently explosive activity. Io's weak gravity and nearly non-existent atmosphere allow volcanic magma to blast hundreds of kilometers into space, forming spectacular lava plumes. Given Io's rampant volcanic eruptions, you may wonder why its atmosphere is so thin and where all the ejected volcanic material goes. The answer lies with Jupiter itself. Io's atmosphere is stripped away by Jupiter's magnetic field, the most powerful magnetic field in the solar system. Buffeted by solar wind, Jupiter's magnetosphere stretches almost all the way out to Saturn's orbit on its night side, vastly stronger than Earth's magnetic field. Io's orbit sits right within the heart of this intense magnetic field, so every particle spewed from its volcanoes gets swept out into deep space, thinning its atmosphere to a barely detectable trace. Io's surface is a patchwork of yellow, red, black, and white hues, colored by sulfur and sulfur compounds released during volcanic activity. With no protective atmosphere, surface temperatures drop to around minus 140 degrees Celsius. Sulfur compounds spewed by volcanoes freeze instantly upon hitting the surface, creating mottled landscapes reminiscent of scallion egg pancakes. Europa, Jupiter's fourth largest moon, is slightly smaller than the moon, with an environment polar opposite to Io's, where Io is carpeted with volcanoes. Europa's surface is a thick, icy shell, with an average surface temperature of minus 163 degrees Celsius. Its polar regions cool even further to minus 223 degrees Celsius, locking all surface water in permanent ice. This also gives it the smoothest surface in the solar system. What's more, geysers erupt from beneath its icy crust from time to time. Scientists are almost certain that a saltwater ocean lies hidden under the ice shell, holding roughly twice as much water as all of Earth's oceans combined. It even boasts an atmosphere primarily composed of oxygen, making it currently one of humanity's top candidates for hunting extraterrestrial life. Ganymede. Ganymede is not only Jupiter's largest moon, but also the biggest satellite in the entire solar system. It is even larger than Mercury and Pluto. If it orbited the Sun instead of Jupiter, it would qualify as a full-fledged planet. Uniquely across the solar system, Ganymede generates its own magnetic field. No other moon can claim this trait. Solid evidence confirms a subsurface saltwater ocean on Ganymede, containing more water than all surface water on Earth, earning it the title of the wettest celestial body in the solar system. Sadly, its oxygen-rich atmosphere is far too thin to sustain life as we know it on Earth. Callisto. Callisto ranks as Jupiter's second-largest moon and the third-largest satellite in the solar system. It bears more impact craters than any other object in our planetary system. Though water exists on Callisto, scientists believe the odds of life emerging here are far lower than on Europa due to its harsher conditions. That said, if NASA's Artemis program succeeds and humans set foot on Mars, Callisto will likely be our next target. Its flat, icy terrain makes it far more suitable for rover operations than Mars. It is geologically dead and completely stable, ideal for building human outposts. Weaker gravity than the Moon drastically cuts rocket fuel costs, and Jupiter's powerful magnetosphere shields it from intense solar wind. The 4 Galilean moons draw their names from Greek and Roman mythology, all linked to Zeus. In legend, they were all his lovers, though the myths tell a darker truth. Zeus coerced and assaulted them, rendering them victims. In Galileo's era, the geocentric model of the universe was universally accepted. This theory claimed Earth sat at the sole center of all celestial motion, with every other body revolving around our planet. Scholars clung to this belief largely because Earth possessed a single moon. They reasoned, if Earth were merely another planet, why would it be the only one with a satellite? For centuries, having a moon was hailed as Earth's most exclusive mark of being the cosmic center. And geocentrism supporters repeatedly weaponized this argument to discredit heliocentrism. 2 major figures championed the sun-centered model, Copernicus and Kepler. Copernicus proposed heliocentrism through astronomical observation, while Kepler advanced the theory even further with mathematical calculations. Using observational data of his time, he proved planets follow elliptical orbits around the sun. Yet without tangible proof, their theories were widely rejected. Critics demanded they first explain Earth's unique moon, leaving both men marginalized and suppressed. Everything shifted when Galileo discovered Jupiter's 4 orbiting moons. Suddenly, a critical question arose. If Earth only had 1 moon and Jupiter had 4, how could Earth possibly be the center of everything? Galileo documented his observations and published them in Sidereus Nuncius, the Starry Messenger. Upon reading the work, Kepler wrote an elated letter to Galileo, overjoyed that years of heated debate had finally reached a turning point. He expressed an urgent wish to own a telescope of his own. Though heliocentrism ultimately triumphed, Galileo's public advocacy landed him in conflict with religious authorities. In 1633, the Roman Inquisition sentenced him to life-house arrest. When people mention Jupiter, the iconic Great Eye immediately springs to mind, the Great Red Spot. It is a colossal anticyclonic storm, oval and rust red in hue, yet it has shrunk dramatically over time. When astronomers first tracked it a century ago, its east-west diameter stretched 40,000 kilometers. By 2004, that width had halved. At its current rate of contraction, scientists predict it will shrink into a perfect circle by 2040, just 14 years from now, losing its oval shape entirely. We cannot tell if this shrinking is a natural cycle, nor what impact it might have on our planet. The storm has persisted for at least 400 years, yet its remaining lifespan remains unknown. To grasp its staggering scale, 2 to 3 Earths could fit neatly inside the Great Red Spot. Its wind speeds also hit Jupiter's maximum, ranging from 430 to 680 kilometers per hour, compared to roughly 300 kilometers per hour across most of the planet. This extreme velocity stems from its position sandwiched between 2 layers of Jupiter's atmosphere flowing in opposite directions, which amplifies its rotational speed. Centuries of study have left many mysteries unsolved. Scientists still puzzle over its rust-red color and its unprecedented longevity. Storms on other worlds, such as typhoons on Earth, usually dissipate within days or weeks, yet this tempest has raged for centuries. Its energy source and the root cause of its ongoing shrinkage remain unconfirmed, along with any potential side effects of its decline. This year, the European Space Agency launched a dedicated probe to investigate the spot, hoping to unlock these riddles in the near future. Few people know Jupiter has rings at all. While far fainter than Saturn's dazzling rings, Jupiter does possess a ring system made of dust and tiny rock fragments, first spotted by Voyager 1 in 1979. For planets in the solar system, host rings, all gas giants: Jupiter, Saturn, Uranus, and Neptune. Jupiter's rings are the dimmest by far, completely invisible from Earth even with telescopes. Saturn's icy rings shine bright enough for amateur Earth-based telescopes to detect. But Jupiter's dust rings reflect minimal sunlight and boast far lower density, rendering them extremely faint. Compounding this, Jupiter's own intense glow overwhelms the delicate ring light, leaving space probes as our only means of observing them. This image of Jupiter, captured by the James Webb Space Telescope on July 27, 2022, delivers stunning detail. It reveals Jupiter's rings, 1 million times dimmer than the planet itself, 2 of its moons, and vivid auroras swirling around Jupiter's poles. Auroras are essentially plasma phenomena, or large-scale electrical discharge events. 3 prerequisites must exist for a planet to generate auroras: a magnetic field, charged particles, and an atmosphere. The mechanism works as follows. Charged particles interact with the planetary magnetic field, collide with atmospheric gases, and produce glowing auroral lights. Both Earth and Jupiter satisfy these 3 conditions, yet their auroras differ drastically. Earth's auroras stem primarily from solar wind. Charged solar particles interact with our magnetosphere, penetrate the atmosphere, and collide with oxygen and nitrogen molecules to create light displays. Jupiter's auroras draw power not only from solar wind, but also a unique, powerful source of charged particles: its volcanic moon Io. As covered earlier, Io's hundreds of volcanoes spew massive volumes of sulfur and oxygen, forming a donut-shaped plasma torus encircling Jupiter. This plasma interacts violently with Jupiter's magnetic field, generating massive electric currents that fuel constant auroral activity. Since Io continuously feeds charged particles into the system, Jupiter's auroras burn nearly non-stop, unlike Earth's short-lived auroral bursts. Earth's most common auroral color is green, produced by collisions between charged particles and oxygen atoms. At higher latitudes, oxygen glows deep red, while nitrogen creates shades of pink, purple, and blue. Jupiter's atmosphere is dominated by hydrogen, so its auroras glow mostly blue and violet, and they shine brightest under ultraviolet wavelengths, requiring specialized UV telescopes for clear observation. This illustrates a core rule. A magnetic field alone cannot produce prominent auroras without sufficient atmosphere and charged particles. Mercury, for instance, has a magnetic field but an ultra-thin atmosphere, so it never displays vivid auroras like Earth and Jupiter. Humans have launched dozens of space probes to explore Jupiter. Below are the most significant missions. Pioneer 10, launched by NASA on March 2, 1972, the first spacecraft ever to fly past Jupiter successfully. Pioneer 11 launched April 6, 1973. Unlike Pioneer 10, its mission extended to Saturn and its rings after the Jupiter flyby. Both Pioneers carried identical gold-plated plaques etched with a human male and female, plus a map marking the Sun and Earth position within the Milky Way. Designed as an interstellar message, the plaques would explain the probe's origin if captured by intelligent alien civilizations. Voyager 1, Voyager 2, NASA launched both craft in 1977. They arrived at Jupiter in 1979, transmitting troves of photographs and data that revolutionized our understanding of the gas giant. Galileo Orbiter, launched 1989, entered Jupiter orbit in 1995. The first probe designed to circle Jupiter long-term. Earlier missions only made brief flybys, while Galileo conducted in-depth planetary research. Juno, launched 2011, reached Jupiter orbit in 2016, tasked with close study of Jupiter's atmosphere, magnetic field, and internal structure. All these missions date back decades. Next, a newer mission launched in April 2023. The European Space Agency's Jupiter Icy Moons Explorer, or JUICE. It will arrive at Jupiter in 2031 after an 8-year voyage. With a 4-year primary operational lifespan, spending twice as long traveling as conducting research. JUICE's core objective is investigating Jupiter's icy moons, Europa, Ganymede, and Callisto, the three water-rich satellites we discussed, to assess their potential to host life. These moons hold unimaginable volumes of liquid water. Earth's surface is 70% water, yet compared to these three satellites, our planet resembles a barren desert. No exaggeration. Astronomers measure planetary water reserves in units of zetahydrospheres, a volumetric metric where 1 ZL equals 1 billion cubic kilometers of water. Earth's total water volume stands at 1.335 ZL, only ranking fifth among all water-bearing bodies in the solar system. The top four are Ganymede, Titan, Callisto, and Europa respectively. Earth's entire water supply does not even amount to a fraction of Ganymede's or Titan's reserves. On Earth, liquid water universally sustains life. So could life exist on these water-abundant Jovian moons? Jupiter is the largest gas giant in the solar system and likely the first planet to form as our system took shape. Mapping the origins and evolution of Jupiter and its satellite system is another key JUICE goal, which will deepen our grasp of how the entire solar system formed. In 2034, JUICE will enter orbit around Ganymede, its ultimate target satellite, a world of extraordinary traits. As noted before, Ganymede exceeds Mercury and Pluto in size and is the only moon with its own magnetic field. Only two other rocky celestial bodies in the solar system generate magnetospheres: Mercury and Earth, both full planets, one of which harbors life. While Ganymede may not host living organisms, the mission will unlock countless secrets about this one-of-a-kind moon. Beyond JUICE, NASA plans to launch the Europa Clipper in 2024. It will reach Jupiter around the same time as JUICE, with its research focus fixed firmly on Europa. China also has an upcoming Jupiter mission targeting Callisto, with plans for a soft landing on the moon's surface. The successful completion of all these missions will vastly expand our knowledge of the solar system's past, potentially reveal its future, and resolve countless unsolved cosmic puzzles. The Jovian system serves as a constant, humbling reminder. No matter how unique Earth may seem, we are merely one tiny body amid the boundless celestial objects of the universe.